So we're gonna do cellular respiration first, and that starts off by NADH,
which comes from the previous cycle, and that so the original energy comes from the sugar, but then the sugar through the other cycles turns into this.
Right, and these come down, they bump into this, and they give up one electron each, and then become NAD+. And these electrons are used here to pump hydrogen protons through here because there's a greater concentration over here, and naturally they want to flow this way. But they need to get over here first, so they're bringing ones over like that and falling through. And then these guys are passed from NADH dehydrogenase into ubiquinone, and they
might have to blowing it.
And as the electrons move down the chain, energy is released, and that's used to pump more protons out of the matrix, forming a concentration gradient, like you said.
And then as these come over here, FADH2 comes down and bumps into this one, and it gives up 2 more electrons, which I don't know if I said this earlier, but Rachel just did, that these are acting as energy to power it. And then these are powered by those electrons, and it brings in some more H's. And then again, these get passed from cytochrome C rehyductase. I wrote it too small.
Okay.
And they get passed on through. And then these charge this again to bring in more H into there. The label.
What is it? Can you say that?
Cytochrome oxidase.
Okay.
So in the end,
So because of the concentration gradient, naturally the H's want to flow back. So they do that through the ATP synthase.
it creates a gradient, so it's sloped like this, and since they want to flow back, they flow through here. And so the gradient, since it's flowing downwards and it doesn't take any energy to flow down, it creates natural energy, like the waterfall that you were saying, when the water flows down.
So as they're going through, ATP is being made.
And that's being made by this spinning and bringing around
like
for a pi to attach to ADP. So the H's flowing through are powering the ATP synthase to be able to create the ATP.
So where's your ATP in phosphate, inorganic phosphate?
So here is our ADP, and these are floating around down here, and as it turns, they get attached to a pi
And then
to make ATP.
What is a pi? What's PI stand for?
It's the phosphate,
Inorganic
inorganic
phosphate.
right there.
that whole ATP.
And that spins, and it brings around more of these, and that just keeps happening to create energy.